Hello, in this video we're going to be learning about the intermediate value theorem and making sure that we can use that theorem in order to verify the value of a function exists, which is going to be neat. So what the intermediate value theorem states is this: if a function is continuous on the closed interval a to b, and k is any number between f of a and f of b, then there is at least one number c in a to b such that f of c equals k. Whew! So what that is talking about is, you can see here, I've got my diagram of A and B. And then we've got over here our f of A. I have black, please. So here's f of A, and here is f of B. If C is some number that's in between these two, so some number in the middle there, there's got to be some point where this function is going to touch this f of c. At some point or another, we need to sort of cross this line if there's a continuity between these 2 points. If we don't have that continuity between those points, then we can't have that in-between value. It can't be applied to something like over here where the function is not continuous. So there is some values in between here where the function doesn't actually spit out that particular value. So let's try it out. Is any real number exactly one less than its fourth power? So we've got some number and we've got its fourth power. But we want the number to be one less than the fourth power. So the fourth power is the bigger number, so we want to subtract one from that. And that's kind of like an equation that we want to solve. Okay, well, it's odd, kind of like polynomial things. So I like to get those things equal to the 0. So we get x to the fourth, not plus, minus. It's x minus 1. And so then I'm looking at that and I'm like, I don't know how to solve that thing. So instead, let's see if we can use the intermediate value theorem to help us out, because I don't need to solve it particularly. Eventually I will, but I just need to know if it exists first. So then I want to say, okay, well, f of x equals x to the fourth minus x minus 1. So now I've got a particular function, and I want to see if the intermediate value theorem would apply. First thing, is this a continuous function? Yeah, that is a nice continuous function since it's a polynomial. Next, we need to make sure that 0 is one of our in-between values that this function could spit out. Well, if we look at f of 0, we get negative 1, so that's a negative number. F of 2 is 13, so it's bigger than 0. So we've got some outputs of our function that are on either side of 0. So we can say by the intermediate value theorem, there exists at least one value c such that f of c equals 0. And just based on those words, you might not necessarily believe it, but hey, look at this graph. So all I did is I graphed my polynomial function, and you can see there are 2 points actually. So the intermediate value theorem guarantees at least one, but there could be more than one time because this function goes up and down. There could even be more than one time in the interval between f of 0 and f of 2. In this case, there was only one. So these are our 2 values. Done. In this example, we need to verify the intermediate value theorem applies and then figure out that value that they're looking for. So the first thing we need to say, okay, well, f is continuous. Hey, come on, don't be like that. F is continuous. We know that because it's a polynomial function, so we're all set. Nice continuous function. Next, we need to see if that f of c that they're looking for, 11, is between 0 and 5. So we check what's going on with f of 0. That is going to be 0 squared plus 0 minus 1. So that is negative 1. And then we check f of 5, see what's going on with that. That is 5 squared plus 5 minus 1, which equals 25 plus 5, 30 minus 1, 29. Okay, well, negative 1 is less than 11, which is less than, what's the thing? 29. So yes, the intermediate value theorem should apply here because we are continuous, and 11 is between negative 1 and 29. In this example, we've got this information about a car traveling along the track. We got its velocity and acceleration, And we want to know, must there be a time when the velocity of the vehicle is -5? Reminder that velocity is how fast the vehicle is going, and acceleration is how much that speed is changing. So is it going faster or is it going slower? So this is just a matter of verifying it with the intermediate value theorem. First, do we have a continuous function? Yeah, they done told us that both acceleration and velocity are continuous. So as stated in the explanation, v of t is a continuous function. So we got the first part. Next, we want to figure out a point where it's on either side of -5. So right here, we've got all these negatives. We go from -10 to 0. -5 is right in between those two values. So we can see on the table that v of 35 is -10 and v of 50 is 0. So v of 35 is less than -5, which is less than 50, -5 being our target number. So we've got continuous, we've got our nice sort of in between. Then, therefore, by the intermediate value theorem, there exists some value c between 35 and 5, where v of c equals -5. All done. In this example, we've got this function g, we've got a couple of the outputs for g, and we're trying to verify, well, which one guarantees that we're going to get 3. So 3 is sort of our in-between number that we've got here. 3 is in between these two outputs of 0 and 5. That's the second part of the intermediate value theorem, but that first part is we need continuity. And so that's why this one's really screaming at me as being the correct answer. So this I feel is the correct one. We don't like this one that is defined for everything, because it could be perfectly defined and then jump and still be defined. But since it's not continuous, then we're not guaranteed something for the intermediate value theorem. The fact that it's just going up, that's not enough. It could be just increasing, but if it increases and then makes a jump increase, that's still increasing, but not continuous. So increasing does not guarantee us the continuity that we're looking for. And this last one about slope, I mean, why are we even talking about slope? We're trying to get this continuity and in between pieces in order to be able to apply our intermediate value theorem. And that's it for their intermediate value theorem. So a reminder that you should be able to use the hypothesis of that intermediate value theorem. Make sure you're talking about continuity and saying that k is some sort of output that's between f of a and f of b to get that f of c that we're looking for. Important things to note is, as you were seeing in the explanations I was giving, they were all written in sentence format. So make sure you're using complete sentences, and make sure you include all of the hypothesis, the continuity, and numbers in between. And that's it. Thanks for watching. Bye-bye.